So the idea is basically some talk about from the software engineer's perspective, the data science project, ML projects, analytics projects, some of the recurrent patterns. Some of them are quite easy to fix actually. Some of them require a little bit of maybe perspective change, and some of them is actually we need to wait for some better tooling. So let's start. A little bit of context and background. I'm an independent software engineer with statistics background. I have been involved, so I'm engineer, so doing software engineering for the last 13 years. For the last 5-6 years, I am more and more involved in projects that has some sort of data science or machine learning component. And in the past also, I did some worked in projects where we built decision support systems, particularly in geographical information systems. And I'm wearing a software developer's hat, which of course implies some sort of bias, and also looking through statistician's glasses, that also implies some bias, and trying to walk in data scientist shoes. I'm collaborating with data scientists and trying to also look from their perspective what is working for them and not. And also, yeah, as I said, I'm observing some patterns. You could call maybe anti-patterns. I'm sharing also, not only in my projects, I'm discussing with heroes. I have friends and they are doing different projects, even in different countries. And so this is a collection of what I observed. Still not a sufficient sample size, so nothing is like conclusive. So I'm very curious about your observations as well. So to start with, this is actually something I found that it has been referred several times in several articles, like I like pyramids. So if you just define the Maslow's pyramid of data science, how we would consider, and if you look into it, like the bottom of the pyramid is about actually collecting data, analyzing, discovery, and then using this data, and then actually self-realization in the Maslow's pyramid, and in data science pyramid is actually AI deep learning. This is actually nice. I like this one. It is pretty tool-oriented or methodology-oriented, but I like to add some other things. Like maybe I see a little bit, maybe a bigger pyramid with a actually bigger part that is in the bottom. So if you discuss about rock bottom, I think we may go to a couple of years ago, more and more companies started to invest in AI and ML. And I think the first thing I noticed was like envy. So because big companies are doing this, and there are many companies in different sizes, they decided to also invest in AI and ML. And this, I think, brings a pattern that I see, that sometimes it's like, feels like it's data science for data science sake, or you can say machine learning for machine learning sake. And what does what does it mean? Trying too many things, because actually there are very challenging domains, and it's very difficult to solve many problems at the same time. So lack of focus, and I see from a little bit from the people, they are envious. They want to do similar things, but also very skeptical at the same time. So there's a bit of this tension I'm feeling. And I think the recipe for this would be defining a clear optimization problem, because even though when we talk about data science or machine learning, it's about prediction, eventually we are trying to solve an optimization problem in the industry. It can be either, you know, like how we are going to increase the sales, or how we're going to cut the cost, etc. It's the optimization problem. So I think it's important that this has to be clearly discussed in any organization. And then the next step was the initiation. So companies wanted to invest more and start to hire people, or convert some people into different skill sets. And the idea was, we will have a data science organization inside the organization, hire the best talent, and let them transform our organization into a data-driven organization. I think the goal is still valid, and it's a perfectly valid, nice goal. What I see, though, is that as a pattern, data science as a separate entity, I think it's changing. Especially, it is not as it was compared to 1-2 years ago. but still I see this, and what it brings, it's silos again. We always discuss. It's very ineffective. One, the most important, there's no clear ownership. So it makes it very difficult to work in this setting. And I think recipe is very simple to say, hard to implement. It is embedding data scientists in IT teams or building teams around data scientists, at least virtually. It doesn't need to be in organizational chart. So another thing is exceptionalism. I say this in a sense that I hear a lot, the data science, as the name suggests, is science, and hence it has to be treated differently than software engineering. And another thing, addition to that, is methodologies like Scrum, Kanban do not work, or best practice of software engineering do not apply. I have some doubts about that. So because I see that data science or machine learning is indeed a science. It's actually stemming from science, but still it's numerical in the sense of it's a numerical modeling. It's not mathematical modeling, 100% at least per se. And most of the things still we are doing in the industrial setting is pretty much like engineering. So what kind of this kind of like a little bit of this way of thinking, what it brings as a pattern? I see mostly agile extreme, so it's like cowboy coding mostly, and it brings quite a bit of unpredictability about the projects. Poor quality also, because when we don't pay attention to the best practices, that's the outcome, and it hampers credibility. That's really, I think, maybe the biggest problem. And solution for this one is, I think, picking and using a methodology. Any methodology is better than no methodology. So I don't have any opinion about which one is best. But there are a couple of things also we can just add to this, like doing pair programming together with data scientists. We can sit together and code together. We can do estimations. It's already difficult for software engineers, and we can think together how we can make better estimations for data science projects, and code reviews. And these are quite actually easy to start with. Yeah, you can start on Monday, next Monday or tomorrow, and some of them require some paradigm shift. And maybe a good candidate will be a CRISPR, because this is actually coming from the data mining community, which actually transformed into, I think, data science and machine learning community. And steps are like very, I think, familiar. So we need some sort of business understanding, and then we have to explore data and clean the data, prepare data, do the modeling, evaluate it maybe with A/B testing or some other form, and then discuss with business and repeat this until we can have a thumbs up for the deployment. And does this actually look familiar for you? I think it looks exactly like Agile. Like, so if you look at Agile or Scrum or Kanban, the methodologies of Agile, I see similarities. So I don't understand how it is not applicable. So I think it is possible to apply one of these methodologies or just mix of it. But actually, when we look at it, I think in most of the organizations, or in some projects, I would say, maybe not the organizations, sometimes we see this picture too. And so it's a corrupted version of the CRISPR. And what is happening is like there's a cut with the IT. There's no clear collaboration with IT and on business. So there's a lot of cycle going on with like data understanding, modeling, evaluation, etc. But in the end, maybe we don't still answer the questions, or we don't solve the problems of the business. I don't know if this also looks familiar for you. By the way, I'm going very fast now, maybe, and we can discuss later on. But if somebody wants to jump, like this I totally don't see, or this is really I see, that's also fine. I think if he is going to.
I cannot really say I disagree, because I just have seen this. So yeah, to answer your question, it looks very familiar. Both the real version and the corrupted one.
Okay, cool.
Because
So
usually when you have the corrupted one, they try to follow the original one, but yeah, because of the issues you mentioned, it doesn't really work. So then you get the corrupted one. Yeah. So yeah, I have really a question on this part since I already interrupted you basically, because I cannot really disagree with what you're saying, but I cannot also not stop thinking that, okay, I'm a data engineer or a data scientist. I land into a team within an organization, especially, okay, probably there are in the audience people that are internals, but as an external, that usually I am in a company. So how far should you involve yourself into this process? It's my struggle is am I there to change all those, or how I should find the balance between trying to change the team or the culture and doing my job and keeping my mental health, let's say.
yeah,
So I struggle with that part, to be honest.
yeah, I have the same. I generally start with quick fixes that is more concrete, and if I see kind of like there's a kind of opportunity, also bringing up the things I'm like, I think it's easy to actually cooperate with business more, and also with data scientists from my perspective. And I think for data scientists, it can be also, I mean, you can always, it depends, of course, in the company culture, but I think you can sit together and say, yeah, can we actually follow up on this one with business, or can we do a pair programming, or can we solve this problem together? So that's a little bit more cultural part. But in terms of methodology and doing things like code reviews, etc., I think they are very, I mean, very well-known things. So it's very easy to apply them.
No, that's for sure. That's for sure. I was mainly talking about things that require paradigm shift. So
Yeah, that's difficult.
yeah, exactly.
Yeah, yeah,
Yeah. So
yeah. So
really hard.
yeah, so I was just talking about this. In this picture, there's a blind handoff to IT, and if you just continue from there, the typical things that I see, that there's this modeling going on, and then the outcome of that iterations, that it is Jupyter notebooks, Python code, HTML model, or anything like that, some sort of artifacts. So hard links to HDFS home directories, or sometimes it's in the local in the computer of the data scientist, and then it's copied around. And then there's this data and configuration scattered through. And this is, we can call this as a tunnel-driven development. It's a well-known actual pattern that we are trying to reach to a point from two different angles, and then it generally doesn't happen. And it's error-prone, slow, and it's an opaque process. It's hard to understand when it's going to end. And for recipe, I think this is something that can be done, and I see it's happening more and more. That the projects can start with a very simple, basic CI/CD. I know that sometimes it's not very clear how the modeling is going to evolve and how it's going to be done, but still the data is being used. There's some sort of, at least there's some idea about what data is going to be used and how we're going to generate the model, and then how we're going to use it. We have to put it in either HDFS or we have to deploy somewhere. So another thing is importing actual source code from notebooks, and then put them in Git. And then using notebooks as a kind of like just a wrapper around them. Doesn't need to be from the beginning, this one, but when the code is a little bit stable, I think this is something that can be done. And as I said, code reviews, because I think we can do pair programming, but data scientists can write code, and the engineers can do the reviews once it is in the Git and with PR pull requests. And also doing some tests with real data, volume and shape. That's really important, because I see some projects are spending a lot of time when the model faces the real data. And also setting sandbox test and production areas very clearly. This is a little bit also system engineering work in organizations, but these are the quick fixes. And another pattern I see, or the thing is that the remake, when the artifacts are handed over, or the code there's a tendency to write in a different language, or with a different perspective. There's a more like I'm seeing this in the software engineering part of the story. And Or the other thing is to extract it to a microservice and say, okay, this is a black box. I don't care what is inside. I don't want to understand. And I will just treat it as a black box, which is not a very bad idea per se. But I think it is also good to know what is happening there and be involved in the entire process. So this pattern is actually, I would call data scientist, software engineer impedance mismatch. It involves a little bit of code elitism, like writing in another language or in another platform. And then I would say this actually is one of the biggest problems in software. Also, the cardinal sin of software engineering, rewrite. It's really waste of time, I think, in many cases. And it can also bring a lot of performance and correctness issues because ecosystems are different. For instance, when you pick something in Python and write in Scala, it's hard to actually prove that it's going to be exactly the same. And the recipe for me is don't fight Python. I'm historically a guy who worked with statically typed languages, but we should embrace when a ecosystem is very powerful and moving on with a great momentum. And again, pair programming, training is another thing. I think it is there's no bad language, if you ask me, but there are bad practices. So we can always share with each other. Pair programming is a great thing for that. And I think data as a contract is a better form comparing to service as a contract. I'm not saying that it is always the case, but if it's possible, it is easy contract and it's generally performs better based on what I've seen so far. Yes, and another one is the algorithm. I see that it's almost always somehow gradient boosting, and with some future interest in deep learning and recurrent neural networks and all the other very flexible algorithms. There's, as I said, I have some statisticians' glasses about that when I look through it. I see when we look at machine learning algorithms, they are very powerful with prediction, but they are not very good with inference. And that actually inference is related to explainability or model interpretability. And a statistical model or statistics as a science had quite a bit of emphasis on inference, and prediction is a little bit weaker. But this brings actually some important things, important perspective, because actually interpretability is very important in some domains and some industries. So when you do resource planning or in supply chain or e-commerce in general, or when you use time series applications, yeah, we can predict. The predictions can be great, but when somebody comes and say, okay, you say that we are going to sell this item for 1,000 units, but it's generally it has been sold for 10. So how does where does it come from? And you would like to explain that to the business because that gives quite a bit of trust, and also these kind of questions are very common. So when we look at the flexibility and interpretability of the methods, so as I said, statistics as mathematical modeling, and when we go in the direction of machine learning, we are doing more numerical, and actually we are moving from parametric methods to non-parametric and numerical, and we see that also interpretability drops and the flexibility increases, and the predictions are better. But and the pattern, and another one is also bias variance trade-off. So it's same, I think, a little bit similar related to this story. And when the models are more flexible, I see that you need more data, and especially one experience I have with time series. It is difficult to get that actually with time series, because and you need a very, very big history, or also you have to do a lot of back testing, and it is a very rigorous process. So a pattern that I see is based on this observations is using algorithms that do not fit the business domain. And I think the recipe is just being a little bit considerate about what do we need more interpretability in this project or in this domain, and what is the volume, and what the data tells, because sometimes actually it is possible to use parametric.
Oh, sorry.
Sorry.
Don't you think that maybe this is a kind of indication of a lack of competency, lack of like identifying which algorithm I should use for this use case, for example?
That is a bit difficult to tell. We'll come to that because sometimes it's difficult, I guess. But what I see is generally for me, as I said, maybe I'm not a practitioner, machine learning practitioner. I'm working with people, but I have some background in statistics. I always hear in many projects that but the data doesn't distribute normally, and but you can actually transform. Sometimes you can, sometimes you can't. But then there are non-parametric methods, and then there are numerical methods, and there are lots of methods. I see that gradient boosting is winning Kaggle competitions, but I'm not sure if it's the right algorithm for every problem. So that's and I think volume and the quality of data is very important. Yes, I see. And also performance. Some algorithms may not perform very well. And then we generally hit that boundary very late in the projects due to the patterns I explained in the previous slides. Yeah, so another one, this is Memento, I would call. So what I see also, Model B beats Model A, and Model C beats Model B, and Model D beats Model C, and Model D is in production. And Model A is drawn from benchmarks, and the Model A was actually never checked against the random RNA model, or Model A was actually a model that business unit had came up, like maybe a business rules based or something very simple, etc. And so it was working, but it was never checked against a random RNA model. I think this pattern is, I would call a little bit, it's a bold one, but it's cargo code science, pseudoscience. We have to be really, really rigorous, I think, and when we are doing this kind of comparisons. And I think it's not very easy and time-consuming, but I assume this is one of the most important activities one team in a project can actually undertake. So this is the recipe. I think it's good to put a random RNA model in the benchmarks. Okay, so another one. What was the problem again? So we spent a lot of time trying to write code and work together, and then modeling and gather data and etc. And then we go deploy, and then we do A/B test, and then business unit comes and says, okay, I see that some numbers are getting better, but some numbers also some key metrics are getting lower. I think that's the natural outcome of an optimization, right? So, but when you don't define the A/B testing criteria, this is very common to see because in general people want all the metrics going up, but this is not possible, I guess. And this pattern is, I think, A/B tests is not clearly defined, lack of collaboration with business. I think this is actually easy fix. Maybe require a little bit paradigm shift too. Define and work on A/B tests early on. I think this is really necessary without even starting with when we define the problem, without starting with working with the data or other modeling activities. So discussing target KPIs, managing expectations, just discussing if it's possible. I mean, if it's logical, what is being asked. So if you just discuss, like I would call this rock bottom of the things, if you go to the checklist. So we want to know what kind of optimization problem we want to solve. Data scientists, software engineers, and system engineers working together in harmony and on a daily basis. We set methodology and best practices, and we reduce impedance mismatch of this tooling of different, I think I would say maybe camps or the societies, let's say, which I think should come together. And we have to define and have actual A/B tests. In some cases, there are no A/B tests either. And CI/CD, a little bit of, I think, investing on CI/CD and making it a kind of a template for data science projects is a good idea. and choosing the right algorithms, not the cool ones, and have baseline models in check. So I'm going to now move to the little bit in the pyramid, trying to climb up. If you would like to go there, what are the things that we also see, and if you can solve? So iterations. If you remember, like in CRISP-M, we said that many projects are not iterating, but there's the idea, right? Actually, you want to have iterations. What I see, there's a ratio of models in production is pretty low, I guess. I don't know how you see it. And models with version beyond V1 is also very few. And also the duration to come to this model in production is very high. It's taking too long. And yeah, this is actually what I said. So what we see that this is the corrupt version of the CRISP-M, or you can say Scrum or anything. And the thing is, I think one thing that we can invest on a little bit, and I see for the recent years, actually, it's growing. There are lots of tooling is happening. That one thing is that we would like to avoid most probably is retraining, manual retraining. And then because there's model decay and drift in live systems, but we generally don't know because we don't monitor. So it's important we do system monitoring. It's always the case, at least in large organizations. But prediction monitoring and data monitoring is something to invest on. So we can check accuracy, precision, recall, and there are other metrics, which is necessary for evaluating the model anyway. And so the pattern is here, fire and forget. I think the problem here is we really missing an opportunity to improve the model and the business value, and also opportunity to learn. And predictions are getting sloppier, and again, loss of credibility. So I think the recipe is here: setting up early on automated training as a separate workflow, and this is a very quick fix actually, and monitoring the data and also the model performance. But there are some difficulties because it is actually saying this is easier than done, because there's this because we are not only working with code in this case, and we have to version data, and this is a little bit different than. Actually, not maybe little, more than a little bit different than the software engineering, because in software engineering we are only caring about reproducible deployments of the code, and the data is generally in databases, and versioning is sometimes a concern, but not always. And here I see that there are some tools like the DVC and MLflow. I'm actually very curious if you are already using, and what are your experiences. What I see that there are other also tools are coming, but one thing I am paying attention is if they can compose, because if they are very UI heavy or trying to do many things, I am a little bit getting skeptical about this kind of tools. And there are some more difficulties in this subject about iterations. How to choose a model automatically. So when we are evaluating, most of the time data scientists look at some metrics, and then they make a choice. But if you would like to do this in an automated fashion, we need really some decisive methods. So they can just decide. We can get maybe reporting about that, but it has to be done automatically. I think there are some non-parametric tests. I wonder if they are very commonly used. So I'm very curious about your opinion about this too. And another thing is that in some companies, production data is not even accessible, especially in banks. And also there is some rigid view about this test and production separation. That requires quite a bit of investment from the architectural perspective. But also it requires some tooling, because data masking and the test data tools are there. They are very expensive. And sometimes people are writing their own for the purpose. But we need some mature tooling and methodologies in this area to be able to iterate and do this in an automated fashion. And data quality. This is something we always talk, but there's something that I see that. So my question is, does data equals to variable? Generally, what I see is that when we speak about data, generally it's more or less interchangeably used with variable and or a column value, or it's a cell in a tabular format. But is that true? And for instance, if you like to define a temperature, the tools that we are using, I think you would define is that a kind of floating point or double. But the question is, what is the value range of a temperature? Is double a good representation for it? And do we need some kind of actually boundary checks? And do we have some tools for that? So same goes for missing data, and same goes for metadata. In the raw form, the data is there. You can of course link metadata and the range and other information, but I don't see very decent tooling around for this kind of issues. And I wonder if you ever used SPSS or SAS in statistical packages. Generally, there's a distinction between data and variable view. So data is really like data that we treat, but also there's a variable view where you define all these things that is necessary to actually check the quality of the data from the beginning. And the pattern I see is fundamental lack of focus for data quality. So poor support for metadata. I see that there are some metadata registries in some organizations, but they are not really in use, or they are not very easy to use, and they are very expensive. Another one is like measure. So what is this data? Is it it's in the scale, scalar, or ordinal, nominal, or what is the unit? And what is the width and range? That's something that is generally goes into the code and or scatter in the code if it's there in first place. So for recipe, I think this is that first we have to address, understand this issue, and then start using maybe some tools. Like I see some one nice tool is Great Expectations. It's not necessarily per se solving all these problems, but at least you can create some expectations in the pipelines and just do some checks about the data. And what I would like to see as a software engineer, that actually there's first-class support for this in the languages. Of course, I think it's possible to write easily a library, and so you can do all these checks, etc. But still, it's delegated to the developer or the data scientist that you have to put that check somewhere in the code, in the execution sequence. So this is also something that I'm really looking forward to see. Another thing is that something I observe that I didn't see that much being discussed, etc. The question is, what is data, information, and statistics? We all know what is it, but how do we reach to information? How do we extract that information from data? And generally, what we do is the data is stored in HDFS or in cloud in similar distributed file systems. And what we do is just we write something with a notebook, Spark, and then the typical query times are mostly seconds for me. If it's not for the case for you, please let me know. And what is bringing is that there's one factor here, that Hadoop is a transactional system. It was built for that purpose. So it is high volume, high latency, and it's actually redundant. And when we look at this, our use cases in the machine learning field or data science, actually you don't need redundancy sometimes, because when the data is there, only the thing we need is to slice, get the data in a quick fashion, and then explore. And then we need actually analytical systems on top of the transactional system, which is not very expensive and does many things easily, perform easily. And what we need is actually low latency environment. So this is actually, the picture on the right is from a blog. I can provide you links. It's 1.1 billion terabytes, and this is the guy is an amazing blog post. There are amazing blog posts there, and the guy is basically in different setups, just running some basic queries. They are all aggregations, some count or some. I don't remember exactly which query which now, but it can show you the contrast between actually the databases which provides not necessarily in a distributed setting, and uses also GPUs. So you can reach to actually sub-second query performance. And when you look at Spark, it's sometimes it takes seconds and seconds. There are some things here. So if you talk about the pattern, it's very slow actually to extract information from data in our current setting that I see mostly. So this brings tedious data exploration and slows down the entire development. And as a recipe, I see that we're considering actually hybrid data storage. One thing is that actually what we are doing is we are extracting data and using the notebooks. One other option could be maybe using databases, not necessarily. I think you don't need to, because most of the time this has a cost, especially from system engineers has to maintain them. But if you think about that, we don't need that much redundancy, and we can always use HDFS data to create the data set in a databases. We can use actually databases for much faster data extraction and exploration. We need some tooling maturity here there as well, but I see that there are the GPU databases not commonly used, but they are interesting. At least there's some development in this front. So if you look at the middle layers checklist, that we need some stable iterations, so non-terminal projects, automated training, live data and model monitoring, make model evaluation repeatable and conclusive, make experiments reproducible. And on the other part, also emphasis on data quality, architecture for transactional, so high volume, high latency, and at the same time, low volume, low latency cohabitation, because one size doesn't fit all in this kind of cases. So we are in middle layers. We will not go up, I think, because I don't know that part that much. This is where I am so far after 5-6 years. But what I see, this is actually something I see, that if you look all these peripheral activities involved in, we are involved in machine learning or data science projects, actually ML code or writing modeling is very small. And the thing is, this is where actually most of the attention is going from the practitioners, and maybe engineers are doing the rest. I think what I see is that, or what I hope, that we have to converge and work together. And I think that we have to understand the needs, because I don't think this is a problem that can be solved by this kind of working in silos or in separate entities. It seems to me that software engineers will need to learn more and more about data modeling and the data, working with data. And I guess just the opposite will be the truth also for data scientists and data engineers as well. So thank you very much. That was it. I felt like it's very monologue because I don't see anybody. And if you have time, maybe we can have some interaction. What do you think, Vivos?
Thank you, Ozgun.